Artificial intelligence does not run on ideas. It runs on electricity, vast amounts of it. And in 2025, the biggest constraint on AI's growth is no longer algorithms or chips. It's power. Behind every AI model, every cloud service, every search query, and every automated system sits a data center drawing massive, continuous energy from the grid. These facilities don't sleep. They don't slow down at night. They don't tolerate outages. And as AI becomes more advanced, their appetite for power is accelerating faster than anyone predicted. This is the context in which one of the most important energy decisions of the decade quietly took place. Google made a $500 million bet on nuclear energy, not on traditional nuclear, not on massive power plants, but on a company building a radically different kind of reactor, one designed specifically for the kind of world AI is creating. That company is Kairos Power. Here on Innovation Corner with Dan, we follow the points where technology ecosystems collide, where energy, computation, and infrastructure reshape each other. Today, we're going inside Kairos Power to understand why one of the world's most powerful tech companies believes nuclear energy is the future of AI. To understand Kairos Power, you have to understand what makes AI data centers different from almost any other energy consumer on Earth. Most industries experience fluctuating demand. Data centers do not. They require constant, stable, high-density power. Even brief interruptions can cascade into massive disruptions. Backup generators exist, but they are expensive, polluting, and designed for emergencies, not continuous operation. Renewable energy alone cannot meet this demand reliably. Solar doesn't work at night. Wind is unpredictable. Batteries help, but they cannot economically store the scale of energy required for large AI facilities over long durations. What AI needs is clean, always-on baseload power. That is where nuclear energy becomes uniquely attractive. But traditional nuclear plants are slow to build, politically sensitive, and often located far from where power is needed. Data centers, by contrast, are often clustered near population centers, fiber networks, and cooling infrastructure. Kairos Power exists to bridge that gap. The company is developing a new type of reactor based on a simple but powerful idea: remove complexity, reduce pressure, and design for safety through physics rather than machinery. Kairos is building a fluoride salt-cooled high-temperature reactor. Unlike traditional reactors that use water under extreme pressure, Kairos's design uses molten salt as a coolant. This salt operates at atmospheric pressure, eliminating the need for massive pressurized containment systems. That single design choice changes everything. High pressure is one of the biggest risks in nuclear engineering. Remove it, and many safety challenges become easier to manage. In Kairos' system, heat is transferred efficiently without the danger of explosive pressure release. The reactor is also designed with passive safety in mind. If temperatures rise unexpectedly, the system naturally stabilizes. If power is lost, the reactor moves toward a safe state without human intervention. This is not emergency engineering. It is fundamental design philosophy. Kairos Power's approach aligns perfectly with what companies like Google care about most: predictability, reliability, and risk reduction. In 2025, Google's involvement is not symbolic. A $500 million commitment signals deep confidence, not just in the technology, but in the timeline. Google is not investing for a distant future. It is planning for near-term energy constraints. AI is scaling now. Data centers are being planned now. Power shortages are being felt now. This is why Kairos matters. Rather than building reactors that feed power into a general grid, Kairos envisions reactors deployed close to large energy consumers, like data centers. This reduces transmission losses, minimizes grid stress, and improves resilience. In effect, power generation becomes localized. We've talked repeatedly about decentralization. Kairos Power represents decentralization at the highest technical level. But this vision is not without challenges. Nuclear innovation has failed before, not because the ideas were bad, but because execution was slow. Kairos understands this. That's why the company has focused heavily on demonstration, iteration, and regulatory engagement. Instead of jumping straight to commercial deployment, Kairos has been building and testing non-nuclear prototypes to validate materials, heat transfer systems, and operational behavior. This staged approach reduces uncertainty and builds confidence. Regulators, understandably cautious, are more willing to engage when they can see systems evolve incrementally rather than leap into untested designs. This patience is part of why Google's bet makes sense. Tech companies operate on rapid iteration, but they also understand the value of long-term infrastructure investments. Google has built data centers, fiber networks, and custom hardware for decades. Nuclear energy fits that mindset. Once built, a reactor can operate for many years with predictable output. That stability is priceless in a world of volatile energy markets. Another reason Kairos appeals to Google is sustainability. AI is often criticized for its energy footprint. Training large models consumes enormous electricity. As scrutiny increases, tech companies are under pressure to ensure that growth does not come at the expense of climate goals. Nuclear energy offers a way out of that contradiction. Clean, carbon-free, always-on power allows AI to scale without increasing emissions. It aligns environmental commitments with operational reality. But Kairos Power is not just solving a corporate problem, it is addressing a systemic one. As AI expands, it competes with households, industries, and cities for electricity. Grids were not designed for this level of concentrated demand. Without new power sources, shortages become inevitable. Kairos's reactors could relieve that pressure by adding capacity without requiring massive grid expansion. That makes their technology relevant far beyond Google. Of course, skepticism remains. Some argue that renewables plus storage will eventually solve the problem. Others worry about nuclear waste, safety, or public acceptance. These concerns are real, and Kairos does not dismiss them. Instead, the company's strategy is to make nuclear energy boring, safe, predictable, quiet, integrated. The goal is not to shock the world, but to fit seamlessly into it, and that may be the most disruptive approach of all. In 2025, Kairos Power stands at a critical juncture. Engineering progress is real. Partnerships are solidifying. Regulatory pathways are opening, but commercial deployment is still ahead. The next few years will determine whether Kairos becomes a cornerstone of AI infrastructure or another promising experiment. But one thing is already clear: Google's $500 million bet signals a shift in how the tech industry thinks about energy, no longer as an external utility problem, but as a core strategic concern. AI cannot exist without power, and power increasingly cannot rely on old assumptions. Kairos Power's reactors do more than supply energy. They create a feedback loop that could reshape AI development itself. High-performance AI models require massive, predictable electricity. When energy is constrained, research slows, experiments are delayed, and innovation stalls. By providing a constant, reliable power source, Kairos ensures AI can scale without interruption. This, in turn, drives demand for more reactors, faster deployment, and smarter energy management, creating a cycle where AI growth and nuclear deployment reinforce each other. This feedback loop has implications beyond data centers. Reliable power allows AI-driven industries, autonomous transport, advanced manufacturing, smart grids to operate at full capacity. Each AI system powered by a stable reactor accelerates productivity and efficiency, increasing energy consumption but also reinforcing the need for more clean, reliable sources. Kairos Power is not just selling electricity, it is enabling an entire ecosystem where advanced computation and nuclear technology co-evolve. In short, this partnership demonstrates a new reality. Energy and computation are inseparable. Companies like Google are betting that controlling power infrastructure is as critical as controlling AI algorithms. And if Kairos succeeds, this AI nuclear loop could define the next era of technological growth. Fast, scalable, and powered by reactors built for the digital age. We believe the future is shaped where systems intersect. Kairos Power sits at the intersection of nuclear engineering, digital infrastructure, and climate responsibility. If they succeed, AI's growth will no longer be limited by electricity. Data centers will hum steadily, powered by reactors designed not for the past, but for the computational demands of the future. And if they fail, it will still mark a turning point, because it will prove that even the world's most advanced companies are willing to rethink energy at the deepest level. In either case, the message is unmistakable. The age of treating electricity as an afterthought is over. Energy is now the foundation of innovation, and nuclear power, once seen as a relic, is quietly becoming one of its most important pillars, where we go inside the decisions shaping tomorrow's infrastructure and explain why they matter today.